Right, so today I'll be talking about discriminant, which is this whole idea of b squared minus 4ac, all right, and I'll be talking about what each of the cases of b squared minus 4ac tells you, right? So, for example, in the first case, we have b squared minus 4ac greater than 0, strictly positive, right? What it tells us is actually basically if we were to solve a quadratic equation and the b squared minus 4ac is greater than 0, then we have two real and distinct roots. If we were to go and draw or sketch the quadratic graph, then that will lead us to having two x-intercepts like this, right? So we're going to look at the first case. So here, for example, we have y equals to negative x squared minus 2x plus 3. And if I were to set y equals to 0, then in the case of solving a quadratic equation is basically just solving negative x squared minus 2x plus 3 equals to 0. So here, in the earlier discussion, what I'm trying to say here is there are two situations. So first of all, b squared minus 4ac is greater than 0 leads us to two conclusions. One conclusion is for the case where we solve a quadratic equation, and that tells us the nature of the roots, all right, the type of solution we get. And the other conclusion tells us how many x-intercepts we should see when we try to sketch or plot the graph. So coming back to here, if I were to proceed to actually solve the quadratic equation, we would have here, all right, and notice that the discriminant of b squared minus 4ac is actually 16, which is positive, all right? Then we actually obtain two solutions here. So these are the two real and distinct roots that we're talking about. So when we say distinct, it means both the answers, both the solutions are different from each other. Right. However, if we were to look at it from the graphical point of view, we also have over here a sketch of it, and we can see that we actually have two x-intercepts. Alright, so when b squared minus 4ac is greater than 0, which is a discriminant is greater than 0, then we also have two x-intercepts for the case where we actually plot or sketch the quadratic graph. Alright, so next, moving on, we have case number 2, where we have the discriminant equals to 0, or the b squared minus 4ac equals to 0. So in terms of the nature of roots, when we try to solve the quadratic equation, we should actually expect to get two real and equal roots. If we were to plot or draw the graph, then we will actually only see one x-intercept, which is here, right? As where my mouse cursor is hovering. So we will look at one example as well, where we have y equals to x squared minus 2x plus 1. And again, if we were to set y equals to 0 and try to solve the quadratic equation, we can see here that we actually only obtain the answer of x equals to 1. And if you were to go and zoom in to the part where I'm actually looking for the discriminant, which is inside the square root, the b squared minus 4ac actually gets me a 0, right? So discriminant equals to 0 means we don't actually just see one real roots, all right? So in this case, what happens is when we actually have this situation, this actually is a repeated root. Now, how do we understand this? Think of it as, in this case, right? So I have originally this quadratic graph, and then as I move the graph upwards, can you see that it is slowly moving towards something like this? So starting from having two real and distinct x-intercepts, right? And then now we move towards having only one visible x-intercept, all right? So in short, if I were to solve for the x-intercept, I actually only get one answer, but this answer came from it being repeated. Okay, so essentially it is like saying this is x equals to 1 or x equals to 1, right? However, as we know, we don't really write it like this, so therefore we just usually put it as x equals to 1 itself. And then for in terms of the nature of roots, we just say 2 real and equal roots. And then for the number of x-intercepts, we will just say 1. So back to this part. The third case would be when my discriminant is less than 0, which is b squared minus 4ac is a negative value. Then what we have is actually, if we were to solve for the um, solution, then we actually do not expect to get any solutions. And then if we were to plot or draw or sketch the graph, then we actually don't see an intersection between the graph, the curve, uh, with the x-axis. So therefore we say that the number of x-intercepts is actually 0. So again, here we have this example: y equals to negative 2x squared minus 3x minus 4. And if I were to proceed to solve this, right, by setting y equals to 0, in the same way as we have done before, you notice that the number inside the square root, which is the b squared minus 4ac, is actually a negative value. Right, so we say that discriminant is less than 0. Now, we know that in this case, we cannot take the square root of a negative number, all right? So we're not going to be able to find a real solution. So therefore, we conclude that if we were to try to solve this quadratic equation, right, then we will have no real roots. All right. So of course, there is could be a pair of complex roots, but that's not in the syllabus. So we'll just conclude it as no real roots. All right. And then if we were to sketch or plot the graph, then we will actually see no intersection, right, between the graph and the x-axis. Right. So we'll say the number of x-intercept is 0.